Hi, so this is the video lecture on measures of center. And last week we started off talking about distribution of data. So the distribution, if you recall, is what are the possible values of the variable and how frequently do they occur? And then we looked at shapes of distributions as well. Well, now we're looking today, this week, at measures of center. So what is the center of that distribution? So there's four measures of center that we're going to talk about. There's the mean, median, mode, and mid-range. And I want to point out that the word average isn't really a proper statistical word to use. It's really a general term for the center. People think the word average and the word mean are interchangeable, but they're really not, and we won't use them that way. So just keep an eye out there. And I also want to point out, I know you've seen mean, median, and mode before, probably since you were in elementary school, but we're going to do this at the college level, so don't completely tune out. So to start with, let's look at the mean. The symbol for the sample mean, we've seen this before, is an X with a bar over it. We call it X bar. You will see it sometimes in journal articles as capital M, but that's not notation that we're going to use in this class. The population mean we've seen before is that lowercase Greek letter mu. So again, sample mean is X bar, population mean is mu. One more piece of notation, and that's the sample size. So lowercase n is the number of observations in a sample. Okay? So at this point, you've got really three symbols you need to know: X bar, mu, and n. So looking at the formula for X bar, this notation up here on the top means take the sum of all the values in the data set. So that's common notation. We'll see that throughout the course. And then we're going to divide by the number of data points there are. So that's just writing the formula a little more formally than we've seen before. Incidentally, as we go through this course, people tend to kind of freeze up sometimes when they see notation like this. Anytime you see a formula, that's really just a set of instructions for doing a calculation. But mathematicians and statisticians, they like to be super efficient. And it has the side benefit of intimidating people, which some of them actually like, I think. Anyway, so we're not going to be intimidated by notation. This is just take the sum of all the observations and divide by however many there are. And I'm not going to go through this calculation because I know you know how to do it. But if you have any questions about that, let me know. All right, the median. Median is the middle number of the data. You have to put it in order first. The particular way you calculate the median depends on the sample size. If you've got an odd sample size, then you just put the data in order from least to greatest and pick the middle number. If n is even, then you put the data in order from least to greatest, and you take the mean of the middle two numbers. For example, here's a data set, 5, 9, 2, 8, 10. We put the data in order. We pick the middle observation, which is 8, and that's the median. Incidentally, there's not really standard notation for the median, the mode, or the mid-range, so we won't get into that. It's just the mean is common enough that it has special notation. Here's another example of the median. We put this data in order from least to greatest. We take the middle two numbers because this is an even number of data points. We take the mean of 6 and 8 and we get 7, so that's the median. The mode is the most frequent observation in a data set. A data set can have no mode, it can have one mode, or it can have more than one mode. So if you've got no data point occurring more than once, the data set's going to have no mode. If you've got two or more data points that are repeated with equal frequency, then you're going to have two or more modes. So here are three examples, and if you want to look at this, go for it, but I'm just going to skip right over it because I know you know how to do this. Mid-range, you might not have seen this before. It's just the average of the smallest and largest values in the data set. So here if you take the smallest is 2, the largest is 12, take the mean of those two, so 2 plus 12 is 14, divided by 2 is 7, so that's the mid-range. And you see, I catch myself, I actually used the word average here, that should be mean. So let me show you how to do the mean, median, and mid-range in StatCrunch and in SPSS. I left the mode off here because the mode is not so easy to get. Alright, so we're going to go to first StatCrunch. And this is the first time we've used StatCrunch, so let me show you how to open it. So from my Stat Lab, just click on StatCrunch. And it's giving me a problem here. I'm going to pause this and get that fixed. Hang on just one sec. Alright, so I have fixed my cookies, and I believe this should work now. Okay, so StatCrunch, you've got some choices here. We're going to pick Visit the StatCrunch website, and then open StatCrunch. So we've got StatCrunch opened, and now what was our data set? Okay. So for this data set, we want to calculate the mean, median, and mid-range. So you can go into StatCrunch and manually type all your data points. But I want to show you something that's going to save you some time. You can copy and just Control V to paste so that you don't have to type all that in. So I will give you, anytime I want you to use StatCrunch to do some calculations, I'll try to remember to give it to you in a form that you can copy and paste. Alright, so here's our data. Now if we want to get the mean, median, etc., we're just going to go to Stat, Summary Stats. So up here at the top, we just clicked on Stat, Summary Stats, and we're going to pick columns because our data is in a column. We're going to pick our variable, so just select it, and then we can pick what we want. Alright, so if we want the sample size, we can do that, and then the mean. So what I'm doing is I'm just hitting Control and then clicking on the quantity I want. So N, I want the mean. I want the median, so Control median. And I'm going to go ahead and hit Control mode as well. So when you do that, hit compute, and this gives us the summary statistics that we asked for. Part of the reason that the mode is not very useful is that there can be no mode, there can be one mode, or there can be more than one mode. And that can be really difficult for computers to deal with. They like to have, you know, one result for everything. And here you can actually see that StatCrunch failed to recognize that there are two modes in this data set. So it only chose the first one. It didn't recognize that 7 is another mode. So that's one reason we don't really use computational tools to get to the mode very often. Let me show you, while we're here, I'm going to ask you on your homework to copy StatCrunch output and put it into your homework. When you do that, just select, just like I did, Control-C, open up a Word document, and Control-V. If you ever have a hard time pasting something like this in your homework, you can go ahead and do a screenshot. So on my computer, I just hit Print Screen, and then go over to the Word document and Control-V, and that's okay too. All right. So that's how to do that in StatCrunch. Let's look at how to do it in SPSS. So this is our variable x. This is exactly what we've done before. We're just going to go to Analyze, Descriptive Statistics, and there are lots of ways to get the descriptive statistics, but the one that I prefer is Explore, because that gives you a bunch of other stuff that we need later on. Alright, so Explore, and we pick our variable, move it over, and under plots, we really don't want the stem and leaf, and right now we're not looking at the histogram. So you can just click Continue, or you can just pick Statistics, either one. So click OK, and this gives us the mean, the median, and if you notice on both of these, they didn't give us the mid-range. We're just going to have to calculate that. So we're going to have to take the minimum and the maximum, add them together, and divide by 2. All right? So that's how to do that in StatCrunch and in SPSS. So let's talk about one big difference between the mean and the median, and that's the effect of outliers. If we were to take this data set, 73, 75, 80, 83, 85, 92, and calculate the mean and the median, they're pretty close to each other. The mean is 81.3, the median is 81.5. Now if we were to change the lowest data point, 73, to 7, meaning that we're changing the lowest point to be an outlier, then look what happens to the mean and the median. The median is not affected at all. However, the mean changes from 81.3 to 70.3. And this points to a big difference between the mean and the median. And that's that the mean is affected by outliers, but the median is not. So if we've got an outlier in the data, it makes no difference whatsoever on the value of the median, but the mean is strongly influenced by that. So now let's talk about, we've got these 4 measures of central tendency. We've got the mean, the median, the mode, and the mid-range. Why would we choose one of them over another? Well, the mean is the one that we usually use by default. The mode is really not useful at all, partly because, as we said, there's not always a mode. Sometimes there's more than one mode. But it does have a use. The mode is used where there's only a few possible values of the data. So like if you're looking at the most frequent number of children in a family, the most frequent number of bedrooms in a house, something like that. So where there's really only a few possible values that the variable could be, That's a time when you might use the mode. The mode is actually also, you can compute that for data that's qualitative. So it doesn't even have to be quantitative to compute the mode, to find the mode. The mid-range is also not very useful. We really only use that if you don't have a calculator with you and you just want to look at the data and get a vague idea of what the center is. So you can kind of eyeball the lowest, the highest, and do a quick head calculation and just see what's what there. Now that leaves the mean versus the median. And the big thing is there, the thing with outliers, like we talked about. If there are outliers or if the data is skewed, usually they'll use the median. And the reason is, if you've got one observation that's really far away from the rest of them, if you've got an outlier, like we said, that's going to skew the mean. When you report descriptive statistics, when you're talking about a measure of center, you want to show something that's really representative of the data. And if you report a mean that's far away from the rest of the data than a lot of the data because it's been pulled by an outlier, that's not going to really be representative. So in that case, they would use the median. If there's not outliers, then it really doesn't matter, and so they'll just use the mean. But almost always when you hear incomes reported, they'll report the median income as opposed to the mean. That's because incomes are almost always skewed to the right. Most people make fairly low income, and then you've got a few Bill Gateses of the world who pull the mean up. So incomes you're almost always going to see described with the median. So now let's talk about measures of center when you look at them graphically. So the mid-range we don't care about graphically, it's just what we're looking at here is the mode, the mean, and the median. So if you look at a distribution, if you look at basically a histogram, the mode is going to be where the highest peak is on the graph. The median is going to be the value of the variable where you've got half of the area to the left and half to the right. And the mean is the balance point of the distribution. So if you imagine that you took a ruler and put the distribution on the ruler and you were trying to put it on your finger to balance it, the balance point would be where you put your finger so that it would balance. And that's going to be the mean. So here's an example of a data set where this one you can see is skewed to the right. The mode is the highest point, so the mode is 1. The median is this place here at 2, where there's half of the data to the left and then half of the data to the right. But if you were going to balance the distribution, if you're going to find the balance point, that would be a little bit here to the right. And if you see the relationship between the median and the mean should make sense, given that the mean is affected by outliers. You see here we've got this outlier, which is going to have an effect on the mean but not the median. So this mean is going to be closer to that long tail. So in general, the one we just saw was right skewed. In general, for data that's skewed to the right, you're going to have the mode being less than the median, being less than the mean. For a less skew, it's going to be the opposite. For a distribution that's roughly normal or symmetric, they're going to be kind of all three right in the same spot. All right, so now let's talk about a particular kind of mean. We frequently see data where the data is not given just as a list. It's given in a frequency table. So here, in this example, we've got 10 18-year-olds. We've got 5 19-year-olds, 3 20-year-olds, and 2 21-year-olds. It would not be correct to calculate the mean of these ages by saying 18 plus 19 plus 20 plus 21 and then divide the result by 4. The reason that's incorrect is that there's more 18-year-olds than 21-year-olds. These don't have equal frequencies, and we need a mean calculation that takes that into account. So here's the formula. So the top of this formula says we're going to take every data point, multiply by its frequency or by its weight, and then take the sum. And the bottom part says we're going to take the sum of the frequencies, and then we're going to divide. So we're going to take every x, so every value in the data set, multiply by its frequency, take the sum, and then divide by the sum of the frequencies. So here's an example. Here's the example we were looking at a minute ago. So ages are x's, frequencies are the weights. So we're going to take every x times f. So 18 times 10 is 180, 19 times 5 is 95. So we've got all of these x times f's, and we need to take the sum of those. That goes in the top part of the fraction, and then the sum of the frequencies goes in the bottom part. So we get a total mean of 18.85. Now let me give you a quick caution. A common mistake people make is that they'll divide by the wrong column. You divide by the sum of the frequencies, not the sum of the x's. Okay, so just be careful of that. Make sure you're dividing the same thing by what you're supposed to be dividing by. And it helps to do a quick sanity check on your calculation. Make sure that the mean should be somewhere in the middle of that data. So if you do a calculation and it comes out not between 18 and 21, let that be kind of a hint that you've done something wrong. So anyway, so here we get the mean age in this class is 18.85. I want to show you quickly kind of where this formula comes from. So this formula, one thing I like about statistics is that if you pick the formulas apart a little bit, you see that there's a reason for doing things the way it is. This example, if I wanted to, I could write it as a list of data. So there are 10 observations in the data set that were 18. So if I wrote 18, 18, 18, so I wrote 10 18s, 5 19s, 3 20s, and 2 21s, I could take the average, take the mean of those using just the regular sample mean formula. So if I did that, it would be all of that added together divided by however many there are, which is 20. Well, to make it a little bit shorter, 18, I've got 10 of these 18s. So I could write that as 18 times 10. And then to save a little bit of time here on the 19s, instead of 19 plus 19 plus 19 plus 19 plus 19, I could just write that as 19 times 5. And then the same thing here with 20 times 3 and 21 times 2. And notice that that's exactly what we do up here. We're doing 18 times 10, 19 times 5, 20 times 3, 21 times 2, and then we're taking the sum. So that's what happens in the top part. And then in the bottom part, we're dividing by, we say, well, there's 10 of the 18s and 5 of the 19s and 3 of the 20s and 2 of the 21s. So what I want you to get from this is that the weighted mean is the sample mean. The weighted mean, it's doing exactly the same thing. It's just a way to write it when you've got the data that's grouped. But when you've got data that's given in a frequency table, this is the format that you've got to do it. Okay, so you've got to use this formula here, or you're not going to get it right. I guess the only other alternative would be to write the data out the long way, like we did here. But if you start getting very high frequencies at all, that's not going to be feasible. So what if instead of frequencies, we gave you relative frequencies or percents? So instead of saying there were 10 out of 20 18-year-olds, we said, well, 0.5 of the data, half the data is 18-year-olds. And instead of saying 5 of them are 19, say 25%. Well, you do exactly the same thing. So you'd say every x times f, so we'd get here 18 times 0.5 is 9, 19 times 0.25 is 4.75. If we take the sum of this column, we get 18.85, and then divide by the sum of these relative frequencies. It just so happens that if you're given the relative frequencies, those all have to add up to 1, so you're always dividing by 1. But the process is exactly the same. So there's a very particular application here I wanted to talk about because it's especially relevant to students. So suppose this is, you find on your syllabus that your grades in a class are going to be calculated according to 5% participation, 15% from your quizzes, 25% homework, 20% a midterm exam, 20% a final exam grade, and 15% from an essay. And this is what the students' grades are. So they calculate their individual grades and they find that they've got a participation average of 80, for example. Well, you just make up a table, and the percentages are the weights. So you just do exactly what we did. You take every x times its weight, add those up, and divide by the sum of the weights. And so the student's average in this course is 85.65. There's just one other thing that we could do with this, and this is something that people ask me all the time. And so I want to show you how to do this so that you can keep a running total of your grade, because I don't really calculate them like this, but you can. So we're going to suppose that we're halfway through the semester, so the student doesn't have all their grades for the entire course. But here's what they do have. They have just this much. So we plug in what they've got. They've got participation score of 80. So far they've got a quiz average of 95. So far their homework average is 82. And so far they got their midterm average of 73. So what's the student's current average in the course? Well, we're going to do exactly the same thing we did before, which is take the sum of the x times w's, so that's 53.35, and divide by the sum of the weights. It's just that here the total weights don't add up to 100% yet. So it's just out of 0.65. So this student's current average is 82.08. All right. So that's it for this lesson, and as always, let me know if any questions come up.